Welcome to this lesson for developing technical skills competency for business needs analysis. In this lecture, we cover identification of processes to apply machine learning. The learning objective of this video is business process analysis and techniques in telecommunications to apply machine learning. For this purpose, we start with what is a process and the need for business process models. Then we compare in contrast the process standard frameworks and practices, followed with the role of business processes in enterprise architecture. Elaborate more on TM Forum frameworks, its structure, decomposition and levels of processes. Also understand how the process translates business strategy by looking at examples of mapping between process elements, aggregate business entities and applications. We then go through an overview of business flows and an example of end-to-end business flow. After understanding the business process flow, we will cover business flow optimization and discuss about business drivers, opportunities, and framework to leverage data analytics, artificial intelligence, and machine learning. Alright, before we start understanding telecommunication processes, first let's understand what is the definition of process. Let's visit TM Forum process definition. It states, a process describes a systematic sequenced set of functional activities that deliver a specified result. In other words, a process is a sequence of related activities or tasks required to deliver results or outputs. Key things that are there is set of activities. So what is being done? They are sequenced. So when you do them, in what order, and it's defined by results and their outputs. And the value of process really is in organizing and coordinating business activities that results in improved efficiency. So we get best practice and best sequence of necessary activities that improves effectiveness by focusing on the outputs and results. That way, the process focuses exactly on what is expected by the business. Let's understand why process models are needed. Business process models are needed to provide a blueprint for categorizing and standardizing business processes that can help set directions for system and organization decisions. Provide an industry standard reference point when considering internal process reengineering or working agreements with other enterprises or suppliers. Provide a structure for defining and managing business processes, leading to improved service quality, improved resource management, and better risk management. When we mention business process models in telecommunications, the key stakeholders in telecommunications mostly rely on TM Forum Business Process Framework, namely ETOM, and our Information Technology Infrastructure Library, that is ITIL. So when we talk of processes or business process models, it's important to understand where to look for process framework or best practices. Especially for telecommunications, it's important to have some background of ETOM and ITIL, their principles and their use and value. On the left hand side is ETOM and on the right hand side is ITIL for comparison. ETOM is Enhanced Telecom Operations Map, now called as Business Process Framework, basically provides consistent process structure and terminology. And it's really a classification of categorization scheme which enables us to develop consistent end-to-end process flows and then to reuse those processes. The key thing is that it's part of enterprise architecture framework called frameworks. So together with ETOM, SID and TAM, they provide an enterprise architecture framework. Started in 1988, generally we get a new version every year or 18 months and intermittent small updates. Current version is release 20. It started purely telecom only. It's an international standard aligned with the ITU, which is International Telecommunications Union. namely M.3050, and it's vendor and service provider driven. So the TM Forum members are mainly equipment vendors and major service providers. Principles of ETOM are global, not for profit. It's kind of kept under independent in a way because to be fair and safe environment for around 900 member companies. Only their member vendors and service provider can come in and collaborate across the telecom value chain. And again, the goal is to improve the agility and efficiency of IT and operations in telecommunications. ITIL Information Technology Infrastructure Library, it is a collection of best practice processes to service-based approach to manage technology, well-defined processes to find language and metrics, and it's built on best practices across industries. ITIL is a division of UK-based Best Management Practice, now under Exelos Global Best Practice. They have Prince2 among other management practices. Started in 1989, upgrades are less often. Currently, the version is ITIL V4 since 2019. And it's very strong in certification. So for you to really use it, one must be certified. Linked to the ISO. And again, the idea is people get certified with ITIL for organizations to achieve compliance to ISO. And the main principle of ITIL is again non-profit, and it's attached to the British government. It's technology independent, it's tool independent, and it's software and vendor independent. And it's kept that way because of backing from the government. To broadly compare the perspective of telecommunications, the use and value of ETOM and ITIL, let's first look at their uses. ETOM covers all aspects of telecoms. In fact, it covers everything for telecommunication entities for which you want coverage today. But specific to the purpose, it's used in product lifecycle, service and networking engineering, fulfillment and operations. Comparing that with the ITIL on the right hand side, it covers all aspects of IT across all industries. In telecom, it is used for all IT processes. A lot of ITIL practices are used in service and network operations, such as incident management and problem management. ITIL is pretty strong in customer care, service desk processes, etc. Again, to compare and contrast the value, both are internationally recognized in telecommunication industry as they both provide a common language. Getting onto the differences between ETOM and ITIL, ETOM helps identify gaps in processes and helps clarify roles and responsibilities. Also, because ETOM is part of a frameworks architecture, it also assists the frameworks architecture. ITIL, on the other hand, is built on best practices and proven to reduce cost of running functions. ETOM, or Business Process Framework, is part of enterprise architecture. An enterprise architecture is a structured methodology for the explicit description and documentation of the current and desired relationships among strategy, business processes, information, applications, and technology. Thus, a business strategy is implemented by offering business services delivered through processes that run data, managed by applications, and deployed on technology, network, and IT platforms. The business processes are translating business strategy into effective IT and technology solutions. ETOM exists within part of this TM Forum frameworks, which is an integrated business frameworks. Just to give the names, it consists of 4 documents. There's the frameworks integration framework document, which describes how the whole thing integrates together within a telecom enterprise in the enterprise architecture context. ETOM, the business process framework. And then we have the SID, the information framework for defining the information there. TAM, the application framework, which has the applications and the software development. The key thing is that there's already predefined mappings. So if we develop our processes in ETOM, then there's an easy way of developing them in the information in the application. First, let's start with the ETOM benefits. 6 things that you can do using business process framework are: create a common language for use across departments, systems, external partners, and suppliers, reducing cost and risk of system implementation, integration, and procurement. Adopt a standard structure, terminology, and classification scheme for business processes to simplify internal operations and maximize opportunities to partner within and across industries. Apply disciplined and consistent business process development enterprise-wide, allowing for cross-organizational reuse. Understand, design, develop, and manage IT applications in terms of business process requirements so that applications will better meet the business needs. Create consistent and high-quality end-to-end process flows, eliminating gaps and duplications in process flows. Identify opportunities for cost and performance improvement through reuse of existing processes and systems. Next, in TM Forum frameworks, we look into the benefits of information framework or shared information data model. Reduce integration costs by adopting standards-based information models and using them in applications and interfaces. Save hundreds of design hours by starting with a major framework and 1500 entities developed and vetted by subject matter experts. Speed time to market by using well understood integration interfaces based on the information framework, eliminating the need for data translation between systems. Avoid wasting precious development time on debates with other team, partners, or vendors by adopting a widely proven, industry accepted, rich and extensible information model. Mandate conformance to the information framework and save time and money during vendor evaluation and procurement. Further, when we look at the benefits of the application framework or TAM, streamline procurement by using common definitions and language to specify and evaluate solutions. Document and then rationalize your application inventory during transformation projects or mergers and acquisitions. Integrate faster and with lower cost by defining and clearly communicating the functions provided within each application. Reduce custom development costs with modular standard application requirements. Increase automation and efficiency with standard deployable components. Let's review ETOM structure. ETOM is structured in terms of functional layers as horizontals and processes as verticals going down the stream. We have functional layers, namely market, product, customer. We have service, we have resource, and we have supplier partner. And then on the right hand side, we can see our vertical processes going down. So we have the two main groupings, and they are traditionally called as SIP, which is strategy, infrastructure, and product. And that's really the long-term planning and so forth. Translates to the capital investments and expenditure. And then we have day-to-day operations, handling sales, handling customer complaints, service activations, charging, billing, etc. So kind of operational expenditure. Now let's look at SIP verticals in more detail. Strategy and commit processes are responsible for the generation of strategies in support of the infra and product lifecycle processes, and business commitment to support these strategies. They provide the focus within the enterprise for generating specific business strategy and gaining buy-in within the business to implement the strategy. ILM or infrastructure lifecycle management define, plan and implement all necessary infra as well as all other support infra and business capabilities. PLM or product lifecycle management understand the market across all key functional areas, the business environment, customer requirements, and competitive offerings in order to design and manage products that succeed in their specific markets. Define, plan, and implement all products in the portfolio. Manage products to required profit and loss margins, customer satisfaction and quality commitments, as well as delivering new products to the market. Product development is mainly a project process that develops and delivers new products to customers as well as new features and enhancements for existing products and services. Moving right are fab operation processes, namely fulfillment, assurance, and billing. Fulfillment provides customers with their requested products in a timely and correct manner, informs the customers of the status of their purchase order, ensures completion on time, as well as a delighted customer. Assurance is responsible for the execution of proactive and reactive maintenance activities to ensure that services provided to the customers are continuously available to SLA or QoS performance levels. Billing supports prepayment for services, produces timely and accurate bills, provides usage information to customers, processes and collects payments, handles customer inquiries about bills, provides billing inquiry status, and resolves billing problems to the customer satisfaction in timely manner. Finally, the operation support and readiness. Supports operational readiness in the fab processes, important for the successful implementation of customer self-management. Let's understand process decomposition and levels in ETOM. Process decomposition breaks a process into smaller components and reveals finer levels of detail. It does not mandate any flow relationship among the processes. Level 0 comprises of the 4 process areas: customer, SIP, operations, and enterprise management. Process groups are part of level 1. Level 1 identifies process groupings, that is both vertical and horizontal, within the level 0 framework and provides the overall business process framework view. It also provides high-level framework. Level 2 provides further decomposition of the level 1 groupings, helps define processes within the group, such as service quality management or resource performance management. Now, before moving with further decomposition, let's spend a moment on how the processes are decomposed in ETOM as per GB 921P. Each of the decomposed processes, X1, X2, and X3, can be further decomposed. For example, X2 is shown as decomposed into X21 and X22, and this can be continued. For example, X21 is shown as decomposed into X211 and X212. It also shows that not all process elements can be decomposed. This will depend on the scope and the content of the processes involved. The process decomposition approach has general characteristics. It defines components of a process that perform part of that process, provides insight into the structure and content of the process areas or groupings, reveals finer detail of lower levels as decomposition proceeds, can be continued to as many sublevels as are needed, aims a complete analysis of the process under decomposition. It represents a static perspective of the process and does not mandate any flow relationship between the process elements. Okay, now in continuation of that explanation, a process is decomposed to a subprocess. There can be further levels of subprocess elements for each subprocess. These subprocesses typically allows high-level systems architecture, enables the evaluation of capabilities against business objective. Now, if we consider business process models, the next level of decomposition is procedures for subprocess. And they describe procedures contained within the subprocess, used to identify the high-level procedures associated with a manual activity, identifies specific systems, technology, and organizational boundaries, identifies where business rules will be needed. Next, going with business process models, the next level of decomposition of procedure is a task. Task provides the detailed requirements within a procedure. Outputs include methods and procedures, job aids, mechanized or automated business rules. Now let's start with level 1 categories. What you see is release 20 representation of business process framework, level 1 categories. Namely, we have process groupings into categories or domains of market and sales, product domain, customer domain, service domain, resource domain, business partner domain. And they are vertically grouped into strategy management, capability management, life cycle management, operation readiness and support, fulfillment, assurance, and billing revenue management processes. Additionally, we have enterprise domain processes and common process patterns domain. Prior to release 15, level 1 represented in 9 process groups for the same vertical groups. And they were namely marketing and offer management, customer relationship management, service development and management, service management and operations, resource development and management, resource management and operations, supply chain development and management, supply chain relationship management, and enterprise processes. Level 2 provides further decomposition of level 1 groupings, helps define processes within the group. For example, in service domain, one of the L2 assurance process is service quality management. Similarly, in resource domain, we have resource performance management. Next level of decomposition of L2 processes into sub-processes. An example process, service quality management, can be decomposed into sub-processes, namely monitor service quality, analyze service quality, improve service quality, report service quality performance, create service performance degradation report, track and manage service quality performance resolution, close service performance degradation report. Similarly, for resource performance management, the sub-processes are monitor resource, analyze resource performance, control resource performance, report resource performance, create resource performance degradation reports, track and manage resource performance resolution, close resource performance degradation report. If we were to consider previously decomposed L3 processes from service domain and resource domain, there is possibility for decomposing them further to level 4. For example, in service domain, consider monitor service quality as an example. It can be decomposed as manage service performance quality data, record service performance quality data, correlate service performance event notification. Similarly, the objective of the monitor resource performance processes is to monitor received resource performance information and undertake first-in detection. The L4 elements therein would be manage resource performance data, record resource performance data, correlate resource performance event notification. TMF Information Framework, formerly known as Shared Information Data Model, that is SID, provides standard definitions for all the information that flows through the enterprise and between service providers and their business partners. Information framework provides a reference model for all the information required to implement the ETOM processes. The information framework concepts are domain, that is a collection of aggregate business entities associated with a specific management area. Domains include concepts such as market, sales, product, customer, service, resource, supplier, partner, and enterprise. The next level is aggregate business entities, a well-defined set of information that characterizes a highly cohesive set of business entities that are loosely coupled with entities in other ABEs. All the ABEs mentioned here are level 1 ABE. For example, see highlighted ones like competitor ABE, and service usage ABE. There are few ABEs which will also have level 2 ABEs also. Next is the business entity. Something of interest to the business itself. That may be tangible things like, for example, you have customer, active things such as customer order, or conceptual things such as customer account. Business entities are characterized by attributes and participate in relationships with other business entities. Business entity instances typically move through a well-defined life cycle. Next, an attribute. An attribute is a fact that describes a business entity. Hence, each class of an ABE has attributes. Finally, a relationship is an association of business interest between two business entities or between business entity and itself. Here is a depiction of mapping processes to SID. What you see in picture are process flow, SID and information model. Process can be mapped to SID to determine the key information elements. SID information entities can be used to define the detailed data model requirements. For the purpose of mapping of process to information framework L1 ABs, let us use resource performance management as the process. Also, what you see here is a table of resource domain ABs mapping to primary processes and secondary processes. Remember, an L1 AB is coupled to only one core process. This specific process is denoted as primary. Resource performance ABE is coupled with resource performance management process, which is an assurance process. However, there are other instances where resource performance management is one of the secondary processes, hence those mappings include resource ABE, resource specification ABE, resource test ABE, and resource trouble ABE. This is the TMF application framework, TAM as originally it is called. The application framework is the ongoing TM Forum initiative to deliver an application architecture or framework for use by service providers and others within the information communications and entertainment industries. Each block herein is an application identifier. For example, in service domain, we have service performance management, service quality management, service problem management, and similarly in resource domain, we have resource performance management and fault management. Now let's look at automated association of process to application and vice versa. Again, as an example, let's use resource performance management as the process. Before mapping, let's understand what does resource performance management application do and its functionalities. Resource performance management applications monitor, analyze, and report on the performance of the service provider's resources. Where the functionalities of the resource performance management application include resource performance monitoring, resource performance analysis, resource performance management reporting. An ETOM process ID, namely resource performance management, is mapped to TAM application ID 7.9, resource performance management. Whereas the TAM application type, resource performance management, maps to multiple ETOM processes, namely analyze resource performance, close resource performance degradation report, control resource performance, create resource performance degradation report, monitor resource performance, report resource performance management, track and manage resource performance resolution. Now let's relate the ETOM process flows with organizational end-to-end business flows. Note that it is essential for telecom operators to continually improve their cost and quality position. One of the most renowned and discussed approaches of improving competitiveness is business process management. Business process management is about improving organizational performance through the definition, implementation, and management of operational as well as enterprise processes. Within the context, the definition of efficient and customer-oriented business processes is a crucial factor. The business process framework ETOM comprises of functional process structures, market, sales, product, customer, service, resource, and engaged party processes. A service provider can be structured into core business processes as well as control and support processes. Core business processes consist of the customer-centric processes and three additional process areas: customer, product, and network. These can be seen to represent process domains arranged as end-to-end business streams which show a focus across the service provider for the area of business activity concerned. The customer-centric processes are characterized as being initiated by the customer and ending at the customer. Additionally, the processes involved include all other core processes which are not directly initiated by a customer. The customer-centric processes have several interactions with other three process areas or process domains. For instance, they might be initiated by relevant activities in the sense of CRM at the customer domain, and interactions may include trouble solving in network domain and the product domain. When we focus on the network end-to-end business streams, this domain consists of 6 network processes, which represent the network operations view and interaction within the telecommunications company. Network processes include activities such as order handling, trouble ticket management, billing, capacity management, service lifecycle management, and resource lifecycle management. As an example, let us view the last one of those, that is resource lifecycle management. This process defines, plans, designs, and implements all resources in order to support the introduction, operations, and retirement of market products. The process starts with the evaluation of the market trends, resource-specific needs, and the definition of the resource development and exit strategy. This is followed by the creation of the business plan and definition of the resource architecture and other strategic documents. The design and development of resource solutions are in line with the strategic goals and required resource capabilities. After the implementation and a successful testing phase, the resource is handed over to the operations, which means on SIP or strategy side, it maps to 8 processes, which means on SIP or strategy side, it maps to 8 processes specified in this figure and 2 processes of operations, namely resource management and operations support and readiness, and resource performance management. The same resource lifecycle management represented in BPMN or end-to-end process flow would look as in this figure. The process starts with the evaluation of market trends, resource specific needs, and the definition of the resource development and exit criteria. This is followed by the creation of the business plan and definition of the resource architecture and other strategic documents. The design and development of resource solutions are in line with the strategic goals and required resource capabilities. After the implementation and a successful testing phase, the resource is handed over to operations. While discussing the end-to-end business process flows, we mentioned business process management as an approach to improve competitiveness of a CSP pursued to improve their cost and quality position. Business process optimization is a key component of business process management. So let's get into more specifics of business process optimization for its needs and benefits. Process optimization is the discipline of adjusting a process to optimize a specified set of parameters without violating a few constraints. The most common goals are minimizing cost and maximizing throughput and/or efficiency. Communication service providers continually identify newer ways to improve business process optimization. The purpose is to assess existing processes to increase organizational efficiency. Optimized processes help in optimized business goals. Some of the examples include eliminating redundancies, streamlining workflows, improving communication, etc. Data analytics, artificial intelligence, and machine learning can be leveraged for business process optimization. And here on, we will review business drivers, principles, and opportunities for data analytics, artificial intelligence, and machine learning as enabler. Organizational efficiency can be looked in phases across the board, but if we investigate network assurance, traditional network management techniques no longer work. Instead, business-driven automation is required. So the business goal is intelligent network management, and operators need to overcome operational and business challenges. That is, networks are becoming more complex and dynamic, while operators are facing increasingly fierce competition. High bandwidth services are putting pressure on networks, requiring them to scale and adjust in real time. Need for accuracy in automation and proactive measures to network incidents. One can identify the opportunity or use case and describe it by including these key fields. First, the motivation. Motivation describes the business problem that shall be solved and the business value of a solution. Actors. These are entities involved in the use case, ordered by relevance. Primary actors, supporting actors, and all other actors. Business process model. One should be mentioning the target model that is being referenced. It can be the service provider's process flows or business process framework or equivalents of information framework and application framework. The data sources, a list of every data source that is essential to the success of the use case implementation, ordered by the relevance. Finally, the metrics, a list of metrics that this particular use case will impact. Some of the model use cases where data analytics, artificial intelligence, and machine learning can be applied in the resource domain, the details of which can be referenced from GB 979A of TMF. They are network fault location and recovery, real-time value-based congestion management, real-time customer offload management, proactive experience-driven network repair, optimal network technology utilization. Highlighted network fault location and recovery or proactive experience-driven network repair are potential candidates requiring anomaly detection and prevention. Let's discuss process optimization framework for applying data analytics, AI, and ML. To apply data analytics, AI, or ML, process flow reengineering or process flow optimization is performed on identified as-is process flow. To apply data analytics, AI, or ML, the process flow optimization uses closed-loop framework. A closed-loop framework, also known as a feedback loop, is a framework in which outputs of a system, workflow, or process are circled back and used as inputs in a way to improve the next output. There are fast and slow closed loops. Fast closed loops function on real-time inputs and data. Slow closed loops function on historical data and/or user feedback. As we conclude, here are few references for further study. You are advised to go through various guidebooks and technical specification documents from TMF, ETSI, and ITU, especially if your focus industry is telecommunications. Hope now you will be able to analyze existing processes, and based on information gathered for identified opportunity, you will be able to re-engineer or optimize the process flow to apply machine learning. Good luck and thank you.